I'm Anil Kumar. Welcome to my series on quadratic functions. We'll discuss 6 application test questions. These questions have been asked in last 5 years many times. I hope their solution will help you. I'll also provide you with some solutions which are tricks to find solution in no time. So you can always take a note of these 6 questions, pause the video, copy them, solve, and then look into my suggestions. Let's begin with their solutions now. Question number 1. An integer is 2 more than another integer. So if one integer is x, the other is x plus 2. Twice the larger integer is 1 more than square of the smaller integer. Twice the larger, so 2 times x plus 2. Twice the larger integer is means equal to 1 more than square of the smaller. So square of the smaller, 1 more than, write it at the end. Find the 2 integers. So you have a quadratic equation to solve, clear? So we can just open this up. So we have 2x plus 4 equals to x square plus 1. Bring all the terms so that the coefficient of x square is positive. So in standard form, we normally keep this coefficient positive. So we have minus 2x plus 1 minus 4, right? So which we can write as x square minus 2x minus 3. And that can be factored, and we have x 3 times 1. Bigger number is negative 3 now, and smaller is plus 1. So we get 2 solutions here. So as you can see, the solutions are x is equal to 3 or x is equal to minus 1. So there are 2 solutions, right? Rather, 2 sets of solutions. So if x is equal to 3, in that case x plus 2 is going to be 5. And if x is equal to minus 1, then x plus 2 is going to be plus 1. Do you see that? So these are the 2 integers. I think it's very important to understand. We are talking about integers, and therefore these signs matter. Now let's take question number 2. Determine the value of k so that the line y equals to kx minus 5 is tangent to the parabola 3x squared plus 4x minus 2. So when we have a tangent, right, so when we are talking about a tangent to a parabola, this line, in that case, it touches only at one point, right? So it touches only at one point. That is kind of important to understand. So that means that at that point, we'll have a common point between the parabola and the line. So we can equate 3x squared plus 4x minus 2 to the line itself, kx minus 5. Bring them together. So 3x squared plus 4x minus kx minus 2 plus 5 equals to 0. So that gives you 3x squared plus, now 4 minus k is common with x, and here we have plus 3 equals to 0. Now, if there is a question where you are looking for a tangent, in that case, it really means that b square minus 4ac has to be 0. So in this case, b is 4 minus k. Remember that. That is the coefficient of x, right? So we have 4 minus k whole square minus 4 times 3 times 3. That should be equal to 0. Correct? So we have 4 minus k whole square is equal to, that is 36. Correct? Now let's try to solve this. So if you solve this, you get 4 minus k equals to square root of 36. Now whenever you do square root, you have to do plus and minus. So that means 4 minus k is equal to plus minus 6. So k, taking it on this side, will be x minus plus 6. 4 minus plus 6. That means we are looking for two values. One could be 4 plus 6 and one could be 4 minus 6. So we get the answer as 10 or minus 2. Right? So those two could be the values of k. Now it makes sense if you have this kind of a parabola and if there is a line with y-intercept, then this line could be either coming from this side, right? Or it could be like kind of going like this. You're getting the idea. So both these lines will be tangent, but will have different slope, right? K is the slope here. So one is with negative slope, the other one with a positive slope. Does make sense to you? So we have an answer here, which is k could have two values, k equals to 10 or minus 2. Perfect. Now let's look into the next question. Question number 3 is, determine the equation of a quadratic function that passes through this point and the x-intercept. So when we are given two x-intercepts, we can say that the function f of x will be equals to a times x minus 1 root, which is let's say 2 plus square root 3 times x minus the other root, which is 2 minus square root 3, right? So you can actually open this up, and where you know the point P is minus 4 and 5. So that should satisfy the equation, and you can get the value of A. So expanding this, you could always find the solution, right? However, here is an alternate method which I am going to discuss. The alternate method is kind of like this. When we are trying to solve the equation, which is, let's say, y equals to ax squared plus bx plus c, in that case, the solution of x is minus b plus minus square root of b squared minus 4ac over 2 times a, right? Now, those are the roots. In our case, what roots are given to us? We are given 2 plus minus square root 3, right? So in our case, we are given that x is equals to 2 plus minus square root of 3. Now, clearly, if you compare these two, in that case, what can you say? Well, you can say that this is like divided by 1, right? So if you compare, you can say that the value of a is half, right? So it is like 2a, right? 1. So you can say a equals to half. You can also say that b, since this is minus b is 2, so b is minus 2, right? And you know that b square minus 4ac should be equal to, inside the radical, square root sign is 3. So that should be equal to 3. Now, since we know a and b, we can always find what c is from this particular equation, right? So let's solve it. So we'll work on our b square minus 4ac equals to 3. b is minus 2, so we'll square this up. 4 times a, which is half, and we need to find what c is. Well, so what we have here is 4 minus, that is 4 divided by 2 is 2. 2c is equals to 3, correct? Now, clearly we can take 2c on this side, so we get 2c equals to 3 on this side. We get 4 minus 3, which is 1, so c is equals to half. So we get the value of c as half. Now, if I get from here c as half, we kind of get one equation. And substituting this here, what we get, our equation is as y equals to, a we are saying is half, x squared, b is minus 2, x, and c is plus half, right? So that becomes our equation. But now the thing is that the point minus 4, 5 lies on this. That means if I substitute minus 4 here, I should get 5, right? So basically this equation should be multiplied by the factor a to get us this particular equation where the point lies, right? So let's substitute the point which is minus 4, 5, right? So if I substitute this point, I get 5 equals to minus 4. So we get half of minus 4 square minus 2 times minus 4 plus half, and all this times a, right? So which is 5 equals to 4 square is 16, and that gives us 8, and this is plus 8, and this is half, right? So 16 and a half. All this should be like this, right? So that gives you the value of a as 5 divided by 16.5, right? 8 and 8, which is 16.5. This half. So that is the value of a, 5 divided by 16.5. Correct? So you can actually find the value of a from here. What do you get? You have to divide 5 by 16.5. So you get 10 over 33 as your multiplying by 2, for example, will give you 10 over 33 as the value of a. So this should be 10 over 33, correct? So we get the value of y, which is equals to 10 over 33 times half x square minus 2x plus half, correct? So that is how we get our equation. And when you open this bracket, then you can write down the answer, which is 10x squared over 33 minus 20 over 33x plus, this could be written as 5 over 33. Right, so, sorry, that was 5 over 33. Divide by 2, right? 5 over 33. This is also 5 over 33. So that becomes your function for the given equation, right? So we get y equals to, let me rewrite, 5 over 33 x squared minus 20 over 33, this was 33, x plus 5 over 33 as your answer. I hope you understand the steps which we have taken to solve this question. If you really expand and simplify this expression, it will be very difficult to get this answer. It's a very complicated calculation otherwise. But if you compare with your roots as we did, then 2a is 1, that means a is half, right? Minus b is 2, that means b is minus 2. And then b squared minus 4ac was 3. We got the values, right? And then it was a question of placing this point which added to our complication. However, you got the right answer. Perfect. So this is a good way of solving equations, especially when we have radical roots. Now let's move on. And here is question number 4. We are already midway through. Now it says that a parabolic bridge is 40 meters wide. Determine the height of the bridge 12 meters from outside edge if the height 5 meter in from outside edge is 8 meters, right? So let's make a parabola first. Let's say that is the bridge we are talking about, right? Okay. Now we are given that parabolic bridge which is 40 meters wide. So this distance from here to there is 40 meters. Determine the height of the bridge 12 meters in from the outside. So, well, the middle portion is at 20, right? So 12, we can say this is 10 more. Inside, we want somewhere here. So 12 from inside. So 12 meter in from outside edge. So this is our inside edge. We'll just keep our x's on this side. If the height 5 meter in from outside is 8. So if 5 meter in, it is 8. That means this height is given to us. This point is given to us, which is from here 5 meters. Do you understand? So the coordinates of this point will be, if I keep this as 0, that will be 35. And the height is 8. Correct? So we have a maximum we need to figure out. Okay. But this is 8. and that is 40, correct? So we are given this kind of a bridge. We need to find the height, which is this height, which we need to find when it is 12 meters in from outside. So 12 from here. So from this side, how much will it be? It will be 40 minus 12, right? So that means we are looking for something like 40 minus 12. So if you take away, we get 8, and then from 3, we get 128. So this point, we want to find, it is 28h. We want to find the value of h. I hope that is absolutely clear, right? So let's first write down the equation of the bridge will be a times x. We are taking this at the origin and the other intercept at 40 meter wide. Is that clear to you? Now we are given a point here, and the point is when it says 5 meters in, that means it is 35 meters away from the origin. So the point is 35. It is 8 meter high, right? So we'll substitute this point. So 8 equals to a times 35 times 35 minus 40. Correct? So we have 8 equals to 35 minus 40 is minus 5. So we get minus 5 times 35 times a. So that gives you the value of a as minus 8 over 5 times 35. Correct? So let's calculate this value. So 8 divided by, within bracket, 5 times 35, which is 8 over 175. So we get y equals to minus 8 over 175 times x minus 40. So that becomes your function. Now we want to find the height of the bridge 12 meters in from the outside. So 12 meters in means what? 12 meters in means, as we have shown, 28 meters away. So we'll substitute 28 here. So we get y equals to minus 8 over 175 times 28 times 28 minus 40. And we'll calculate this value. So we have 28 times, within bracket, 28 minus 40. And we are going to multiply this by 8 and divide this by 175. There's another negative which will make this positive, right? So it gives us height of 384 over 25. The negative which you see will cancel with this negative, right? And in decimals, we can write this as 15.36. And the units will be in meters, right? So we have our answer. Height of the bridge, (12 meters in from outside) will be 15.36 meters. Correct. So that is how we are going to solve it. Now, question number 5 and 6. These two questions are based on inverse function. Given f of x is 2x squared minus kx plus 9, find the value of k if f inverse of 29 equals to minus 2. So I'm showing you a very easy method here. So let's understand this strategy. Now, on this inverse function, when we say f inverse is 29 equals to minus 2, right? So that basically means the point is 29 is the x value and the y value is minus 2. So that implies what? It basically implies that on the function, the point should be minus 229. correct? Point should be minus 229. Now we know inverse is not a function, so it's not exact point, but we'll see how do we get the answer, right? So we have minus 229 here. 29 is the y value, so we have, so f of x is basically equal to 29 for x equals to minus 2, right? So we'll substitute minus 2 here, minus 2 square minus k times minus 2 plus 9. So we have 29 equals to 4 times 2 is 8 plus 2k plus 9. So we have 29 minus 9 minus 8 equals to 2k, correct? So let's solve for k now. 29 minus 9 is 20, minus k is 12. So 12 equals to 2k. So 12 divided by 2 is the value of k. We get 6 as the value of k, correct? So we do have our answer here, and we say k is equal to 6. Now important thing here is that we didn't really find the inverse of this function, correct? However, we could get back and get the value of k in the equation using the point. Since the inverse and the function points, they swap, right? That's the strategy. Okay, so I hope you appreciate this. The last question, question number 6 is, write inverse of this function when x is less than or equal to 2. Will the inverse be a function? Explain your answer. So you could always swap x and y and write down the inverse. However, I'm going to again apply a strategy here to find the inverse. Now remember, here the domain is x is less than or equal to 2. As you can see, this is basically a parabola which is going to open downwards, correct? Where the vertex is at 2, 5. So you are restricting the domain to less than 2. That means this side only. So here we know that the domain is x belongs to real number where x is less than or equal to 2. And the range is y belongs to real number where y is less than or equal to 5, right? Now, when we are looking into the inverse, so if it is opening downwards, the inverse will open on the left side. The point here will be the same vertex, but 5, 2. Is it okay? So, and this domain and range swap, correct? So what you have here is that for the inverse, let me write 5 inverse x, right? We'll write the equation also, but here the domain now will be what? Domain will be x belongs to real numbers where x is less than or equal to 5. As far as the range is concerned, that will be this value. So y belongs to real numbers where y is less than or equal to 2. Okay. So you can see it is on the left side, so it is only this part of the curve, right? So less than means we are only looking into the lower half, not into the upper half. So that is our solution, right? So y less than or equal to 2. Does it make sense to you? Perfect? Okay. Now, let's also write down the right inverse of this function. So that's the first part. So if I have to isolate x, what should I be doing? So what I will do here is, this is x value minus 5. This is my first thing, x. I'll take away 5. Then I'll divide by minus 3. Then I'll do square root, right? And then I will add 2. Now in square root, since our restriction is to the left side, we are going to take the negative side. Do you see that? So that becomes the inverse of our function. So even without doing any calculation straight away, we know the graph will be like this, the bottom half, and the equation will be that. And this is going to be our domain and range for the inverse. So I hope that makes sense. So with that, we end this set of 6 questions on quadratic functions applications. Now, I hope you appreciate what we've done here. and you take something from here. These are questions from previous test papers, so they should definitely help you. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.